Full quiet isn't being quiet enough. I want to figure out why. This is GME Wave, a video game music to wave converter I made in 2017. The user could render a song with one or more channels muted, or the user could play one or more channels solo. I wanted muting in the headless front end, even if only for debugging. I added a set of enabled sound channels to the machine state. Adapting GME Wave's command line parser would take a bit longer. I started by writing the help text. If you're just joining, I call this type signed instead of int. This reassures others reading my code that I've thought about whether to make each variable signed or unsigned, because it ties into some of C's undefined behavior gotchas. Because I wasn't dealing with 32-channel tracker modules, I could use integer types with fewer bits for channel bit sets. I looked up whether I could stringify any num in an error message so I could define the channel count once and only once. I added two new long options, one for mute and one for solo, along with the corresponding short options. I pasted in the last of GME Wave's parsing code. I tracked mute and solo separately because if the user specifies neither, the user wants all channels. Though I wasn't clear on what to do if both are specified, I filled the field of the arg struct. I handled syntax errors in channel lists and in my own code. I tested some obviously invalid channel sets. It turns out enums can't be stringified. I had to change channel count to a define. I printed the enable channels in verbose mode. I added muting logic to the channel mixer. I tried it and it didn't mute anything, because I hadn't actually recompiled it. It still wasn't muting anything. I needed to disable channels after initializing the machine. That was better. Next, I wanted to log writes to a range of addresses so I could isolate what a sound driver was doing. That'd be a long-only option. I added the last written address and value to the machine state. A negative value would mean nothing written since the last check. I started parsing the range of interesting addresses, representing no active range as last before first. For that, I had to read 1 or 2 hexadecimal numbers. I put that in a separate function. It would resemble a simplified version of channel set parsing. No hyphen means the range is only the start address. Otherwise, read the end of the range. Allow only one range at a time to start with. The parser compiled. Testing and logging would wait for tomorrow. Yesterday, I started on an option in the headless front end to log values written to a range of addresses. I printed the range in verbose mode. It correctly rejected a backward range and accepted a forward one. I added the logic to check for a newly written value. It logged all writes to one of the sound channels. The triangle channel notes were still sticking. I isolated the triangle channel in a good emulator and in mine. I read the log and it was missing the last address in the range. That was better. It wasn't stopping notes through the channel enable register. It was writing hex 80 to the linear counter. I reread the triangle channel pages for how that ends a note. I had it treat a continuously reloading 0 as still a 0. That indeed silenced it, but it produced flat parts of the wave roughly 1 frame apart. It appeared to stop and restart the note once a frame. I logged envelope changes to tell what was going on. This gave me a bit more to work with, but not quite enough. I had it log length counter changes as well. Length counter wasn't it either. I looked for specific cycle counts to log. I logged each sample where envelope was hex 80 and thinned the log to once every 64 CPU cycles. Found the problem. Writing the high byte of pitch was muting the note until the next envelope tick. That sounded better. I removed excess logging before moving on to the noise channel. I logged values written to noise registers. I suspected the length counter, so I logged it. Noise length counter wasn't getting turned back on, and I'd need a double header to fix it. I logged when the length value gets changed. It was setting the length once and not setting it again. I instead logged when APU control was zeroing length. It was immediately getting muted, even though the program wasn't clearing APU control at the time. I reread the APU control and status register description, and then I realized. A note ending shouldn't prevent the next note from starting. That would conceptually split the APU status and control registers even though they're at the same address with similar bit layouts. I confirmed this theory through log experiments, and then I had APU status directly read the length counters. I made APU control behave more like the key-off register that it is. I isolated noise in a good emulator to know what to expect. I extracted each individual channel to listen to them separately. Noise and triangle had indeed improved. removed. I still needed to double check pulse channels. I started by logging sweep. I hadn't even wired up the sweep register. This meant the sweep unit was muting the first note of the intro, which was in the lowest octave. The intro sounded correct. These changes fixed full quiet and probably other games using a Famitone driver. In August 2010, I made a tech demo called DPCM Letterbox. It uses the interrupt when a sample ends as a makeshift timer. This let me split the screen in more than one place without MMC3 and without the CPU's continuous attention. Firehawk, MIG, and Time Lord do something similar. And it almost worked. It was only missing one thing. The original demo used grayscale mode in the blank parts. Grayscale mode replaces the color of every pixel with a light gray at the start of the row. Timed code can turn it on and off in the middle of the screen. I added names for grayscale and other bits in the same register. Was that it? Nope. I added logging to find what silly mistake I had made. The setting was correct, it just wasn't acting on it. Silly me, I needed to handle grayscale after the palette lookup. There it is. Because the timing for sample playback was so close to correct, the DPCM Letterbox demo's raster effect already pretty much worked. I just needed to put in the one cosmetic feature, which full quiet also uses when the player takes a lot of damage. I could turn off a lot of sound-related logging too. Sound adds more punch when Donnie defeats the zombies. Ralph is back. In the mid-2020s, people started using large language models as sparkling autocomplete for computer programs. They called it vibe coding. A few weeks before I recorded this session, Jeffrey Huntley wrote a script that automates use of an LLM as an autonomous vibe coding agent. It reads a specification, drafts an implementation plan, and loops over the plan writing code for each item. He named the agent Ralph Wiggum after the Simpsons character. I just wanted to reassure you that I will not be using an LLM. English grammar books say don't use quotation marks for emphasis. I'ma do what I want. Ain't no cop gonna arrest me for word crimes. What the scene calls emphasis isn't really emphasis. It actually de-emphasizes the colors on the other side of the color wheel. This means blue emphasis darkens yellow, for example. So far I'd been using a single 64 color palette. I downloaded a bigger palette that has all 8 emphasis states, along with a test ROM that shows all of them at once. I was about to try this test ROM and it lost horizontal sync. Maybe it was relying on the exact length of a frame. The PPU skips a dot every other frame to line up the color phase. I logged frame lengths to see why this wasn't happening. I found the code that was supposed to be skipping a dot. I ran the test in a good emulator to see what it was trying to do. It was trying to skip a dot on the last dot, but you can't push a value past its maximum. I scooted the missing dot one dot to the left, and it worked. I rearranged the headless front end to use the larger palette. This needed changes to loading the palette and writing the screenshot. I looked up how multi-dimensional arrays work in C. Decay of an array to a pointer isn't trivial to understand either. There it was, NES test with an emphasized palette. I had it draw each scanline with that line's emphasis. I was only supporting one emphasis type per scanline to keep the frame buffer from expanding from 8 bits per pixel to 16. Yet it wasn't emphasized. I collected the line's emphasis value even if not rendering. That got the full palette demo working. I made the same loading and output changes to the SDL front end. And it worked. What else could I do in 17 minutes? I searched the web for how to do a basic digital high-pass filter. I'd need to stash the filter state in the machine. I resisted reading about Stack Overflow politics while on the clock. I looked up the corner frequency of the NES's high-pass, which determines its time constant. I ran a low-pass filter on the signal to estimate its DC level, and then subtracted that out to produce the final signal. It's slightly quicker to calculate if the time constant is a power of 2 samples, such as 2 to the 8th equals 256. I thought I had it working, but it never filtered anything. I'll save you 6 minutes of struggling with filter topology. Suffice it to say I had a line in the wrong place. Today at my day job, I worked hard on a background boss routine. A background boss can be moved around the screen like a sprite, but it's part of the background. Squeezing a background boss between the status bar and the floor is hard work, even if you have an MMC3. It left me with little stamina for coding. I figured out why the high-pass filter wasn't working yesterday. I was saving the filter state in a branch of the downsampler that never gets called unless downsampling is turned off. Did that fix it? Looks like it did. I thought of something I could do with the stamina I had left. Run the MDFourier test ROM and compare its output to other emulators. I opened the output from family size VM in Audacity. I could see the effect of the high-pass filter, with the crests of 1/8 pulses farther from center than the troughs. The spectrogram looked fairly clean, without much reflection around half the sample rate. There was still a missing hardware pitch sweep. I designed the MDFourier pattern for NES to fit in 2 minutes. A recording in FLAC format of a console playing a test pattern takes an estimated 4 megabytes a minute, and at the time, Discord limited uploaded files to 8 megabytes. I'll measure emulators' high-pass filters from these step responses. I was still using the linear approximation of triangle noise and sample channel mixing. I recorded the test pattern in FCEUX and in Mesen. Sometimes emulators try to be too clever by half and dump saves, movies, and recordings into a hidden folder. I had to fish them out. I found one on the desktop. I got all 3 loaded and checked their overall volume. My overall volume was close to Mesen and quieter than FCEUX. I compared spectrograms to look for aliasing. I noticed Mesen on the bottom has reflections off the top, and mine in the middle lacked even harmonics of triangle because of approximate linear mixing. I still haven't figured out how to get a horizontal scroll bar in Audacity. On half-duty pulse waves, I had less aliasing than Mesen, but slightly more than FCEUX on top. Nothing to worry about at the moment, but I had the messiest high-frequency buzz noise. Cleaning up my notes. The high-pass step responses look fairly similar to one another. Once I got done looking around, I'd post the notes to a chat room, so I wanted them to look presentable. Now Audacity decides to give me the horizontal scroll bar after I click the real-time effects button. I'll be so glad when the MuseScore devs fix the UI for Audacity 4. I could really see the aliasing in Mesen sweeps. I continued polishing my notes, making sure I was using the right terminology for time constants. Once I finished that, I brought back our wobbly friends, Cornelis and Ralph. I named the horn player Cornelis based on a suggestion by viewer RT55J. I gave him a Dutch name given that he's from a prayer book published in the Dutch-speaking part of Belgium. See you tomorrow!